Hello ladies and gentlemen, this is video number 4, I think, that I'm making this morning at stupid o'clock in the morning. Oops, sorry about that. So this is for Algebra 1 Goal 3. I have a couple of students who are in Goal 3. Most of them are a little bit further than where I'm going to be right now, but a couple of the topics that I'm dealing with are specifically DSA topics, and I want to make sure that we are all, back to basics, know what we're doing, we're comfortable with how to go through the things that we're getting ready for as we start prepping for the DSA. So we're going to be covering vertical line test, identifying functions from relations, table for linear equations, and identifying solutions. These two in particular are almost interchangeable with each other. I want to talk about them briefly. And then the vertical line test, I always get a lot of questions on, and I also always get a lot of questions on identifying functions from relations. Technically, I could probably talk about reading a point on the coordinate plane and plotting a point, but generally speaking, students have either already tested in and have that memorized from pre-algebra goal 5, or more specifically, they can figure it out and learn it pretty fast. Like, there's not really much for Ms. Dubois to add to that particular conversation. But first things first, let's talk about our first item on our list, which is the vertical line test. So let's zoom in a little bit. There's our thing. So, vertical line test. As can be sort of assumed and expected, you need a vertical line. Ta-da! Now, through the miracle of Photoshop, what I'm going to be demonstrating is going to be pitifully simple. For those of you who don't have Photoshop and honestly don't have on a Chromebook the material necessary to do what you need, oops, let me fix that. There we go. Now I'm all set. The easiest way to do it is, if you have your student ID, just hold it vertically on your screen to do what I'm about to do, and that usually makes things easier for you. Or failing, if you don't have your ID, the drama, anything that's straight, like a piece of paper or a pencil or something like that. So what I'm going to do is I'm going to take this little vertical line, and I'm going to just visually draw it across a graph. That's ultimately what they're looking for. When I'm taking this line and I'm pinging it along the graph, the thing that I'm always making sure that I'm doing is that I only pass through one point at a time. That's important enough that I need to write that down. So deselect. So only, I'll make that thinner, pass through one point at a time. Okay, so as I take this little vertical line and I start moving it over, as I'm pinging it back and forth, I'm asking, does it pass through one point? Yes. Does it pass through one point? Yes. Does it pass through one point? No. Fail. Done. That's all you're doing for this, okay? So next up, come on, computer. Oh yeah, deselect. Oh, this is gonna suck. Whoa. Oh, my purple disappeared. Oh well, we'll live. Okay, so next up, take my vertical line here, and now I'm going to move it over. All right, so far I'm not passing through anything. So far I'm good, so far I'm good, so far I'm good. And then pass it through here. Well, that's exactly 1 point, but what if I go further? Oh no, it's 2 points, the horror. It can't work, so it's a fail. Okay, next up. And you can start to sort of see what kind of things that you're looking for here. V, and then look over here, passes through only 1 point, good, passes through only 1 point, yep, good, passes through only 1 point, yes, passes through only 1, passes through only 1. So we are good. This is a pass. All right, so far so good. Next, we're going to take this and move it down here. So that didn't work. Wrong tool. Now these ones here, the ones that have the open circle and the closed circle, you kind of need to take them on a case-by-case basis. The thing that you need to remember is that the open circle means that at this specific point, so where x equals 2, this doesn't actually exist. You can get as close as possible. You can have 1.999999999 to infinity, but it's not actually going to hit to 2. It jumps down here. But then that makes you think, okay, so then Ms. Dubois, this is a pass. So it passes at this point, that is true. Does it pass at this point? No, it's a fail. All right, next. If I drag my little vertical line over here, I can already tell at a glance that this is going to be a fail. because it's a circle. Like there's no point here where it's only going to pass through one point unless you're looking at the extremes. This one visually for students is a little bit harder to see because even as I'm passing it through, I mean it like looks like a one point, but you're not sure. My Algebra 2 kids will know this a lot better because God knows they are buried in that particular shape right now in their topics. This is a pass. And as you go through, you can see it again. I'll demonstrate it again. As I'm moving this along, only one, 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 only one. It never passes through a second point. It is only ever one at all times. So the good news is for these topics, they come with like 6 different examples. So going through tends to be really fast. And after a while, you start to get a little bit better at it. So you can see, okay, that one's a fail, that one's a fail. Let's see here. The others I need to maybe check. So let's go through these. Move this over. Only one, only one, only one, only one. So this one is a pass, and it starts to speed up after a while, okay? Now I'm going to take this and drag it down here. Only one, only one, only one, only one, only one, only one, only one. This one's a pass. Good. So far, so good. And for my Algebra 1 kids, this line in particular, you're going to be very, very familiar with for the next several chapters. Basically, this is 3, 4, and 5 all deal with a straight line like that. So, nope, got a fail right off the bat. As I move through that, it passes through 2 points instead of 1. And now we have the tricky one over here. Let's see here. Let's see what happens when we get there. We know that over here it passes through 1 point, so okay, fine, I kind of like it. But if I move further down, is that through only 1 point? Nope, it crosses the purple in 2 places, which means then that this is a fail. So that's what a vertical line test does. So that means this topic has now been complete. We can check this one off. I'm so sad that the purple's gone. Let's get it back. Okay, next up is going to be identifying functions from relations. This is another one where kids can sometimes get a little bit confused on what it is that they are trying to do. What you're ultimately looking for is when you have the setup like this, you come in 2 flavors, you can tell. You kind of have your list of topics, or you have this little flow chart. What you're visually doing is you're actually completely covering up the range because you fundamentally do not care what the range is for now. Next chapter, goal 4, the range is going to matter very much. What you're looking for, though, visually is you're looking at this. It only points to 1. Pencil only points to 1. Cloud only points to 1. Cloud strife, I'm waiting for Final Fantasy VII. Lake only points to 1. So, much like up over here, it can only go through at 1 point. Down here, it's the exact same thing, therefore it's a pass. So, next up, if I take this and then move it over here, visually cover it up, where it's pointing doesn't matter. Like, it could be pointing to the same thing for all I care. It's not going to change anything. The question you're asking is it only is pointing to 1? Yes. Pointing to 1? Yes. Pointing to 1? Yes. Points to 1? Yes. Points to 1? Yes. This is a pass. The question then, Ms. Dubois, is what happens when it's a list? Well, if this is your x, comma, y, and you learn that in other topics, then the only thing you're interested in is the x, because the domain is your x and your range is your y. The range we don't care about, it's the domain we're looking at in order to make sure that it is a function. So, n, m, m, n. The question you are asking yourself is, does it repeat? Both of these numbers repeat, and so long as one of them repeats, it's a fail, not a function. -8, 4, -2, 4. 4 repeats, therefore it's not a function, all right? So, next up, down here, does it repeat? M, U, T, B. Do any of these repeat? Nope, all of these are unique, therefore it's a pass, it's a function. 6, 6, nope, fail. It's going to be not a function because the minute your domain repeats, as soon as this number pops up anywhere else, it's a fail. That's what you're looking for, and that's the whole point of this kind of test. Let's see here. -2, 1, 3, -8. None of these are the same number, therefore it's a pass. R, K, K, nope, fail, because the K's started to repeat. That's what this particular topic is going to be doing identifying functions. Whoops, wrong button. Identifying functions from relations. So that's 2 of these that are now done. Okay, next up on the list, table for linear equation and identifying solutions. I had already mentioned that these are very similar. You're basically kind of doing the same thing, and one example on the topic gives you multiple occurrences of doing the same thing over and over. So it actually becomes very repetitive and very rhythmic as a result. So let's start with that first one, table for a linear equation. So here are 2 examples set up for ourselves. Let's give myself a little bit of room to work. So look at this. They tell you what your x is every single time. They give you a whole bunch of x's, and then they give you an equation, a formula. Well, good gosh and golly gee, if they give you an equation and they tell you what x is on a silver platter, what are you going to do? You're going to plug it in. So it's negative 4 times whatever they give you plus 5. In this case, what did they give you? Negative 5. So what's negative 4 times 5? 20 plus 5, 25. There's my first one, 25. Okay, next, a little bit bigger. What's the next number they give you? It is negative 3. What is negative 4 times negative 3? 12. What is 12 plus 5? 17. There's my next number. And you're starting to realize, oh, this actually isn't that bad. We can do this. Next one is, what's our next number? 0. That's going to be 0 plus 5, so your answer is 5. Okay? For those of you who have mental math skills, this topic goes by even faster if you have your mental math skills. And you know Ms. Dubois is the human calculator, and I'll show it in the next one, but I want to make sure that we're comfortable with what we're doing. So what's our next number? Our next number is 3. Negative 4 times 3 is negative 12 plus 5. Negative 12 plus 5, they're opposite signs, so I'm subtracting. 12 is the bigger number, so that's the sign that dominates, and then 12 minus 5 is 7. Negative 7, okay? Next up, see, not even the signs are slowing us down because we've been doing sign work with positive and negative numbers for so long that we're starting to get comfortable with this. And then 4, some 4 and 4, that's negative 16 plus 5, and then that's going to be negative 11. Ta-da! And you start to realize how easy this is going to be. Again, this will be negative 3 times whatever they give you minus 1. So, Ms. Dubois speed. Negative 3 times negative 3 is 9. 9 minus 1 is going to be 8. Negative 2 times negative 3 is positive 6. 6 minus 1 is going to be 5. 0 is going to be negative 1. That's easy. And then negative 3 times 2 is negative 6. Negative 6 minus 1 is negative 7. 3 times negative 3 is negative 9. Negative 9 minus 1 is negative 10. Yeah, that might have been a little insane now that I just realized I recorded that. Sorry, let me do that a little bit slower so you guys can follow what I did. Negative 3 times negative 3 is going to be 9 minus 1. That's where the 8 is coming from. Next up, we're going to be doing negative 3 times negative 2. That's going to be 6 minus 1. That's where the 5 is coming from. Next up, negative 3 times 0 is just 0. 0 minus 1. That's where the negative 1 comes from. Then negative 3 times 2 is negative 6 minus 1. Same sign as addition, so 7 plus, so 6 plus 1 is 7. That's why it's negative. Negative 3 times 3 is negative 9 minus 1, which is going to be negative 10. That is a lot better. I feel more secure in myself. Good job, Ms. Dubois. All right, so then this is all, if you'll notice, with one variable. The next topic handles with 2 variables. And this one, even Ms. Dubois kind of needs to do this out by hand. I can technically do this in my head, and students have seen me do this in my head, but it's a little bit harder to just mentally track. Your brain needs to be really organized for this. So what do we have? We have 7 minus 6 equals 19. And now what the question is what's our x and what's our y? So in this case, what's our x? Negative 4. What's our y? 0. So 7 times negative 4 is negative 28. 6 times 0 is just 0. It disappears. 19. Does negative 29 equal 19? Nope. And that's all you're doing for this topic. Again, all you're doing, they give you that equation on a silver platter, and then they tell you what the numbers are. So all you're doing, exactly like over here, is you are plugging in your numbers and then solving for the numbers that they give you. Whoops, good job, Mr. Block. Scroll. Lag. Scroll. Not that far. Computer! All right, so what do they give us? 2 and 1, so we're going to put in 2 and our negative 1. 7 times 2 is 14. Double negative is a positive. 6 times 1 is 6. And so does 14 plus 6, that's 20. Does that equal 19? No. Next. All right. What are the next numbers that they give us? We have -5 and -3. 3 is Dubois. I can write. So 7 times -5 is -35. Oof, I don't like the look of that. Double negative is a positive, so that's going to be 18 equals 19. Let's see here. Those are opposite signs, so it's going to be negative something, and we're looking for positive 19. Again, I can cheat a little bit here because I'm starting to get to the point now where I can start to look ahead. I know -35 plus 18, whatever answer I have, it's going to be negative. The 19, the number that I'm trying to reach for, that has to be positive. So I don't need to go through the effort of the extra computation. We can if you want to. So 35, that'll be 17 equals 19, and we proved ourselves to be correct that this is not a viable solution. Next up, what's the last pair they give us? 7 and 5. That's interesting. I don't quite know how that's going to work out. 7 times 7 is 49. 6 times 5 is 30 equals 19. 49 minus 30 is 19 equals 19. So this one, at last, is a pass. It took a while. Okay? Next up, for each ordered pair, determine if the solution is y equals 0. So because we've done so many examples where all you're doing is plugging in and solving, I did want to point out that once in a while they give you a curveball, especially for this topic, where they give you something like this, y equals 0. Because how do you plug that in? Like, how does that actually logic? Well, if we're looking at y equals 0, we're going to look at our y's. Which ones are 0? That one. Is that one a 0? No. Is that one a 0? No. Is that one a 0? No. So even when they try to trick you, the work that they're giving you is actually not all that bad. So, in conclusion, up here and then fill screen, we have computer. We've done several topics in a row, 4 rapid fire topics, all of them very fast to do and also very easy to do. You don't always get the two at the same time. So this is a benefit to you, and this is a proof, or at least starting the proof of the idea that Algebra 1 Goal 3 is pretty easy. You can get through it very, very fast, and hopefully this will help you guys as you start prepping for some of your DSA questions. Next time we'll start talking about these later parts of the topics, and I will see you in the next one. Stay happy, stay safe, stay healthy.